Okay, today we're going to talk about how we can use logs in real life situations. We're going to talk about compound interest and how to use logs to solve those types of problems. And then there's a second set of notes where we use logs to talk about how to figure out half-life decay problems. I don't know if y'all have done it yet in chemistry. Y'all might have talked about half-lives. We are going to actually use logs to solve those types of problems. So I think it's kind of cool, especially to see how to use it in real life. So let's go ahead and start out with compound interest. At the top of your notes you have your formula. A equals P parentheses 1 plus R over N to the NT power. The NT, both of those are in the exponent. So we need to talk about what each letter represents. Okay, the A represents the amount after T years. Okay, so that's why we give it the letter A. It's the amount after a certain time. Okay, the P is for the original amount invested. There are some formulas, if you Google this, that won't have the P. They'll have an A with a little O, standing for the original amount. The reason some people put the letter P is because of, we call it the principal amount. So like if I go open a bank account, the deposit would be the principal. It's the money I put in at the very beginning into that account. If I go buy a house or a car or something like that and I put down a deposit, I have to pay the principal amount, the very beginning amount, and then so much after that. But that's why sometimes you'll see an A with a little subscript O for the initial amount, and sometimes you'll see a P. They're the same thing. But I just want to let y'all know if y'all ever Google it, I'm not crazy. The R stands for the interest rate. Now the thing about your interest rate, whenever you put your rate into your formula to solve these equations, it has to be in decimal form. So they'll give you your rate, like they'll say, okay, you have this bank account that you invested $200 in that, I don't know, pays 6% interest every year or annually or whatever. You're gonna have to change that percent to a decimal before you actually solve. So interest rate in decimal form. If you don't change it to a decimal, it will be wrong. Okay, they will always give it to you as a percent, pretty much always. So you're gonna have to change it to a decimal. All right, the N stands for the number of times per year the interest is compounded. And your problem will tell you. So like if it tells you that your account pays annually, okay, you're gonna ask yourself, okay, if it happens annually, how many times does that happen every year? And it'd be once. It happens once a year. Annually means every year. It'll say monthly. So how many times would that happen every year? And there's 12 months in a year. So the N would be 12 if it's monthly. Quarterly means it happens 4 times a year. I don't think you'll have a problem like this, but bi-weekly, you can figure out how many times a year that happens. Weekly, 52 times a year. There's 52 weeks in a year. So we'll talk about that more with the examples that we see. But N is the number of times the interest is compounded per year. T is the number of years that the interest is compounded. So it'll tell you how many years we want to figure out, or if it doesn't tell you, that's what we're solving for. And we'll see some examples, okay, and it'll help make this make sense once you see some examples and see how it's done. Okay, so what I do for every single problem is I'll write down A equals P equals R in T, and I'm going to fill in my blanks with what it equals, and then I'm going to solve from there. But I always write this down every single time. That way I don't forget anything, and that way I know exactly what I'm solving for and what I'm plugging in, stuff like that. Alright, so let's look at number 1. Number 1 says, if Heather invested $2,000 in an account that earns 10% compounded semi-annually, how much will she have after 20 years? Okay, so we need to ask ourselves, like, what is the amount, what is the principal, what's the rate, our N, our T, all that stuff. Okay, if she invests $2,000, that's what she's putting in. That's our initial amount. So the $2,000 would be our principal, our P. Okay, in an account that earns 10%. 10% is our rate. Now we have to change that 10% to a decimal. So to do that, you take your decimal and you move it to the left 2 spots. So it's 0.1. Okay. It's compounded semi-annually. So if it's semi-annually, how many times does that happen per year? Okay, semi would be 2. So my N is 2. How much will she have after 20 years? So they give us a time, 20 years. So what's left, what we need to figure out is our amount after that time. So I'm going to plug in my numbers into my formula. Remember, it's at the top. Your formula is A equals P, parentheses 1 plus R over N to the NT power. Okay, so I'm going to plug in all my numbers. P is 2,000, parentheses 1 plus R is 0.1 over N, which is 2 to the 2 times 20. Okay, so I can punch all of this in my calculator all at once, okay, because I don't have any variables here. So you're going to put it in exactly like this. 2,000 parentheses 1 plus 0.1 divided by 2. Close your parentheses. Okay. Then you're going to put the caret button, push the caret button, 2 times 20. Make sure both the 2 and the 20 are in the exponent. It's a really small number. Okay. So go ahead and punch that in. I'm going to give you a little bit to get that punched in, especially since this is the first time we're doing this. Okay, and we're talking about money here, right? We invested $2,000. How much are we going to have after 20 years? So when you get your answer, you need to round to the nearest penny, since we're talking about money, right? So you should get that the amount after 20 years is $14,079.98. Okay, if you did not get that amount, you need to check how you put this in your calculator. Should be 2,000 parentheses 1 plus 0.10 divided by 2 close parentheses 2 times 20 in the exponent. Okay, and help each other out. If someone's having trouble punching in the calculator, let them see how you did it. Okay, but yeah, help each other out. Not all the problems are going to be this easy, where all you have to do is punch it in and you get your answer. Like I said, today we're learning how to use logarithms to actually solve our problems. So we're going to have some problems where we have to use logs to solve. Okay, but we'll go through examples together. Let's look at number 2. If Heather wants to have $5,000 in the account after 10 years, what does her initial amount need to be? Okay. So like I said, on every single problem, I write A equals P equals R in T. Okay? And I fill out this chart, so to say, and figure out what I need to solve for and what I need to plug in. So, let's see. She wants to have $5,000 in her account after 10 years. So, the $5,000 is not the initial investment, it's how much she wants to get back out. So, the $5,000 is actually your A. We don't know how much she needs to put in to get that amount. That's what it's asking you to find. The time would be 10 years. Let's see. Now, this number 2 is based off the last problem we did. We're still talking about Heather. So our rate is going to be the same, 0.1, and our N will be the same. Okay, we just want to figure out how much would you have to invest if she wanted to get $5,000 back out in 10 years. So our rate and our N would be the same for this problem as number 1. Alright, so let's plug these numbers in. My formula is A equals P, 1 plus R over N, and all of that to the NT power. So I'm going to plug in my A. I don't know what P is. I'm going to plug in my rate, my N, and my T, which is 10 years this time. Alright, now I'm going to punch in the calculator everything that I can. So I can't put in P, that's a variable. We don't know what it is. But I can put the whole rest of this right side of the equation in my calculator. Right? I can put in parentheses 1 plus 0.10 divided by 2 to the 2 plus 10. Right? 2 times 10. I'm sorry. So go ahead and punch that in. You should get 5,000 equals, I'll give you a second. Okay, when I punched in parentheses 1 plus 0.1 divided by 2, close my parentheses, caret button, 2 times 10, I got 2.653. Okay, so make sure you get that. Now, if I want to solve for P, the opposite of multiplying by this 2.653 is dividing by 2.653. And I'm going to do that to both sides. Okay. Just like the last problem, we're talking about money. So whenever you put this in your calculator, you want to round to the nearest penny. Right? And so Heather would have to invest $1,884.66. if she wants to get $5,000 back in 10 years. Okay, at this interest rate, at this bank, in this situation. Okay,